Welcome to the deep dive. Today we're looking at the hidden mechanics of industrial real estate. We are bypassing the standard residential market entirely and getting straight into the high-stakes, multi-million-dollar world of commercial zoning, brownfield remediation, and structural risk.
It is a massive space, literally and figuratively.
Exactly. Whether you are managing a real estate portfolio, scaling an industrial operation, or you simply want to understand the massive physical architecture that keeps the global supply chain moving, you are in the right place. We're unpacking the exact frameworks used to value, analyze, and ultimately sell these massive properties. Joining me to dissect this intricate web of engineering, law, and high finance is our resident expert in commercial asset valuation.
Glad to be here. This is a sector that operates on a completely different frequency than what most people are used to.
Yeah, I mean, when you drive past a 500,000 square foot distribution center, it just looks like a big concrete box, right?
Right, but you aren't just evaluating a structure. You're evaluating an intersection of municipal planning, environmental science, macroeconomics, and intense liability management. The margin for error is razor thin.
And the capital involved is just staggering.
It really is. I'm looking forward to breaking down the actual mechanics of how these deals are constructed and, honestly, how they fall apart.
Let's start with the foundational categorization. Before anyone can value a property or market it, they have to understand exactly what kind of physical asset they are holding. The industry segments these massive structures into three distinct categories. Let's start with the baseline. The general purpose building.
The general purpose building is essentially the broad market index fund of commercial real estate. It's diversified by design.
So if we use an analogy, it's like a basic t-shirt. It fits almost everyone.
That's a great way to look at it. Developers build these structures with the explicit goal of capturing the widest possible tenant base. They feature standard clear heights, standard column spacing, and standard power drops.
It's all about risk mitigation, isn't it?
Entirely. If you have a logistics company leasing this space and they happen to go bankrupt, a general purpose building is versatile enough that you can just pivot. You can lease it to a light manufacturing firm or a commercial printing operation with minimal structural retrofitting.
That makes perfect sense. You buy flexibility. You have a predictable asset with a broad pool of potential buyers. But as we move up the scale of complexity, we hit the second category, which is special purpose buildings.
Right. If the general purpose building is your index fund, the special purpose building is more like a sector-specific ETF. It has a defined, limited market.
So it's a tailored suit, not a basic t-shirt, but not a spacesuit either.
Exactly. A prime example is a facility constructed with heavily reinforced floors. A standard poured concrete slab might handle typical pallet racking just fine, but if a tenant is operating massive stamping presses,
Or stacking really dense raw materials.
yeah, exactly, metallurgical raw materials, a standard floor will suffer catastrophic failure under that weight. It'll crack, it'll settle, and eventually compromise the entire foundation. So a special purpose building will have a highly engineered, thickened slab, maybe with specialized epoxy coatings.
And the trade-off there is pretty clear. You can charge a premium to the specific tenant who desperately needs that specialized flooring.
But if they leave, you have a much smaller pool of prospective tenants willing to pay that premium.
Right. A standard warehousing operation won't want to pay elevated rent for a heavy-duty floor they don't actually need.
And that means the asset becomes less liquid. The time it takes to find a suitable buyer or tenant increases, and your carrying costs during that vacancy period can severely impact the internal rate of return.
Which brings us to the extreme end of the spectrum, the single-purpose building. This is your spacesuit. Incredibly expensive to make, but almost impossible to resell to someone who isn't an astronaut.
That is the perfect analogy. This is where the real estate asset and the business operation become almost indistinguishable. A single-purpose building is a highly leveraged, illiquid investment.
We're talking about structures like oil refineries, right? Or specialized chemical plants.
Smelting operations, heavy manufacturing. These are architectural monoliths built around one singular, unalterable process. The physical structure is entirely subservient to the heavy machinery inside it.
So the piping, the ventilation, the containment silos.
They are all custom engineered for one specific application.
And the financial liability there is massive. If that specific industry faces a downturn, the building doesn't just lose value, it essentially becomes a liability.
Because the cost of conversion is generally not economically feasible.
You can't just sweep out a decommissioned oil refinery and turn it into an e-commerce fulfillment center.
Exactly. The demolition and remediation costs alone would likely exceed the value of the underlying land. They are notoriously difficult to appraise because there is rarely a direct comparable sale in the market.
If you are representing a seller of a single-purpose building, you aren't really looking for a real estate investor, are you?
No, you're looking for an operator in that exact same highly specialized industry who happens to be expanding at that exact moment. It is a needle in a haystack scenario.
Okay, let's unpack this.
Yeah.
This inherent risk in older, specialized structures naturally drives the market toward redevelopment, right? When an industrial asset becomes economically obsolete, the value shifts entirely to its redevelopment potential.
Redevelopment is where the most sophisticated capital in commercial real estate operates. It requires a tremendous amount of vision.
You're looking at a massive, aging-heavy industrial site and calculating the cost of gutting the interior, remediating the environmental issues, and subdividing the footprint.
The goal is usually to pivot the asset toward the prevailing economic winds. Today, that usually means creating multi-tenant facilities for light manufacturing or last-mile logistics.
And within that redevelopment strategy, one of the most fascinating models is the incubator building.
The incubator strategy is brilliant in its pragmatism. Developers take these massive, older properties, chop them up into much smaller, low-rent units, and specifically target growing early-stage industrial tenants.
So you have a demographic of tenants like startup manufacturers, artisanal food producers, specialized hardware designers.
People who have outgrown a garage or a shared workspace, but who lack the credit history or capital to sign a 10-year triple net lease on a pristine warehouse. They need a stepping stone.
So the developer provides that stepping stone, but they do it knowing that tenant retention is actually not the primary goal, which is so counterintuitive for real estate. The entire model is built on high turnover.
Precisely. You are intentionally leasing to companies that you hope will outgrow the space. If an incubator tenant is successful, they will inevitably need more square footage, heavier power drops, and more loading docks.
They move out, and you lease that space to the next startup, often at a slightly higher market-adjusted rate.
It requires intense, hands-on property management, but it allows an investor to generate immediate cash flow from an aging asset while they hold the land for future, more intensive redevelopment.
Knowing the redevelopment potential is crucial, but it leads us directly into what might be the most perilous aspect of industrial real estate, the land itself.
Ah, yes, the brownfields.
When you are dealing with older industrial sites, particularly those primed for redevelopment, you are almost invariably dealing with brownfields. Under Ontario brownfields legislation, a brownfield is defined as a vacant or underutilized property where past industrial or commercial activities have left the soil or groundwater contaminated.
Which naturally brings up the immediate question any rational investor asks. Why take on the massive liability of toxic land?
Right. Why bother with the headache?
The answer lies in urban infrastructure and simple geography. You have to look at where these brownfields are located. A century ago, heavy industry was built along rail lines, rivers, and deep water ports.
Which are now the absolute geographic centers of major metropolitan areas.
Exactly. These sites possess what developers call in-place infrastructure. They are already wired into high-capacity municipal power grids, heavy-duty water and sewer mains, and they are surrounded by existing transit networks.
If a developer were to buy a pristine piece of agricultural land on the exurban fringe to build a new facility, the hard costs of pulling municipal services out to that site would be staggering.
You'd have to widen the roads to accommodate truck traffic, fight the resulting zoning battles. It's astronomical. The in-place infrastructure of a brownfield often offsets the cost of the environmental cleanup.
And beyond the raw economics, there is a massive legislative push to revitalize these areas. We have the Ontario Brownfield Statute Law Amendment Act, which was engineered specifically to catalyze this process. It operates on four main objectives, right?
Yes, four main pillars. First, it is about accessing valuable land resources. Municipalities simply cannot afford to have prime urban acreage sitting dormant and generating zero tax revenue.
Second, it aggressively addresses liability issues, which historically paralyzed this entire sector.
For decades, if an investor bought a contaminated site, they assumed the full legal liability for that pollution, even if a previous owner caused it 50 years ago.
That liability piece is the fulcrum of the entire brownfield market. But the legislative framework now provides mechanisms.
Things like a record of site condition, which offer a degree of liability protection from environmental orders once the cleanup meets specific, rigorous standards.
The third and fourth objectives of the legislation grease the wheels financially and administratively. The Act empowers municipalities to provide direct financial assistance and tax relief.
often through tax increment equivalent grants given to developers who take on the burden of remediation.
And finally, it streamlines the planning and approval process.
Because time is the ultimate enemy of the internal rate of return. A faster path to building permits makes the underlying financial model viable.
Here's where it gets really interesting for the people putting these deals together. The risks are still profound, particularly regarding the stability of ongoing income.
Oh, absolutely. If an investor acquires a commercial property and discovers an undisclosed underground storage tank leaking hydrocarbons into the local water table, the remediation orders from the Ministry of the Environment can instantly bankrupt the operating entity.
This places a massive burden of due diligence on the buyer and, by extension, the real estate professionals facilitating the transaction.
This is a critical juncture where we must define boundaries. A commercial real estate salesperson is navigating a minefield, but they are not the bomb squad.
I love that phrasing. They aren't the bomb squad.
It is explicitly established in commercial practice that salespersons are not expected to possess the technical expertise required to evaluate complex structural, legal, or environmental anomalies.
They are not hydrogeologists, they are not structural engineers, and they are not corporate attorneys. Their role is risk identification, not risk diagnosis. They are looking for the clues.
Precisely. They are the initial filter. However, their responsibility regarding source documents is absolute. A salesperson must verify facts strictly from primary source documents.
If they rely on a seller's verbal assurance regarding square footage, zoning designation, or environmental history, and that information proves false,
They have actively participated in the misrepresentation of the asset. This distorts the buyer's income and expense projections and opens the door to severe litigation.
let's quickly break down the architecture of that due diligence, because it is generally categorized into four incredibly dense pillars. The first is financial and operational.
The forensic accounting phase. You are looking at certified income statements, balance sheets, and the rent roll.
And analyzing a commercial lease is not like reading a residential rental agreement.
Not at all. You have to understand base rents, additional rents, common area maintenance chargebacks, and specific escalation clauses. You also have to scrutinize operating expenses.
Are the property taxes accurately assessed? Are the utility costs historically consistent? Every operational penny must be verified to ensure the net operating income is accurate.
The second pillar is legal, which extends far beyond basic title searches. There is a stringent requirement to verify the identity of the transacting parties using source documents to comply with NTRAC regulations.
MTRAC, which is Canada's anti-money laundering and anti-terrorist financing framework. A lot of people might be surprised to hear that in a real estate context.
Commercial real estate is a known vector for capital flight, and the legal compliance here is rigorous to prevent fraud.
Beyond that, the legal pillar demands strict verification of zoning compliance. You must obtain the current zoning bylaws directly from the municipality and cross-reference them with the actual current use of the property.
Assuming the current use is legally permitted is a fatal error.
The third pillar is structural. This involves commissioning a comprehensive building inspection report. A specialized commercial inspector evaluates the physical systems, reviews maintenance logs, and identifies physical deficiencies.
And those deficiencies are categorized. Some are simply deferred maintenance, like a deteriorating asphalt parking lot.
Others are material facts, like a compromised load-bearing column or a failing roof structure. A material fact alters the fundamental value of the asset and must be disclosed.
The final pillar brings us back to the environmental risk. The due diligence here requires a physical visual inspection of the site and a review of all provincial and municipal records.
If there is even a hint of a problem, like a suspiciously patched concrete floor, or an orphaned ventilation pipe protruding from the ground, or records indicating the site was a dry cleaner in the 1970s.
The process stops, and third-party environmental engineers are retained to conduct a Phase I environmental site assessment.
But knowing the environmental risks is really only half the battle. You can have completely uncontaminated soil, but if the massive concrete structure sitting on top of it is functionally obsolete, you still have a compromised asset.
Which requires a rigorous physical assessment, starting with understanding how the building is aging.
Let's talk about the bones of these buildings. In commercial appraisal, age is a bifurcated concept. You have the actual age, which is simply chronological, the number of years since the certificate of occupancy was issued.
But the metric that truly dictates value is the effective age. Effective age is a measurement of economic utility based on condition and maintenance.
So it's highly subjective and fluid.
Very much so. You could have a heavy manufacturing facility with an actual age of 40 years. But if the ownership group has continuously reinvested capital, upgrading the power grid, replacing the roof membrane, installing highly efficient LED high bay lighting.
Reinforcing the loading docks.
Exactly. That building functions and competes in the market like a facility built 10 years ago. Its effective age is 10 years.
The inverse is equally true, and probably far more common. A facility built just 15 years ago that has suffered from deferred maintenance will have an effective age closer to 30 years.
Ignored roof leaks, bypassed HVAC compressors, damaged concrete slabs from careless forklift operation. The capital expenditure required to bring it back to a competitive baseline must be subtracted from its market value.
To accurately gauge that effective age, you have to understand the baseline anatomy of the modern industrial asset. What is the industrial aesthetic? When you walk onto the floor of a general-purpose logistics facility, the architecture is driven entirely by the geometry of storage and heavy machinery.
You are typically looking at a massive single-story expanse, and the critical vertical metric is the clear height.
That's the unobstructed distance from the floor to the lowest hanging ceiling element, like a joist or a sprinkler head. Historically, clear heights hovered around 16 to 24 feet.
But modern logistics dictate clear heights of 32, 36, or even 40 feet. The higher the clear height, the more vertical racking you can install, which fundamentally increases the cubic volume of rentable space without increasing the property tax footprint.
Beneath those racks, you have the most critical and often the most expensive architectural element, the concrete slab. We are typically talking about a poured concrete slab at least 6 inches thick.
But the thickness is only part of the equation. The concrete must be meticulously cured, often reinforced with steel rebar or synthetic fibers, and sealed to prevent dusting.
Dusting can ruin sensitive electronic inventory, right?
Absolutely. And looking upward, the roof structure in these massive spaces is almost universally supported by open-web steel joists, or OWS.
This specialized truss system provides incredible structural rigidity while remaining relatively lightweight.
More importantly, the open webs allow contractors to route miles of electrical conduit, compressed air lines, and sprinkler pipes through the joists themselves, maximizing the clear height below.
But the physical shell is just the beginning. The internal operations of these buildings have undergone a massive technological evolution. An industrial facility is no longer just a passive container.
It is an active node in a highly automated supply chain. The operational efficiency of the building dictates its value.
We are seeing the deep integration of wideband radio frequency technology. In a facility spanning 1 million square feet, standard Wi-Fi is completely inadequate.
You need robust, zero-latency communication networks to instantly transmit inventory data from the central servers directly to the onboard computers of forklifts or crane operators navigating aisles a quarter-mile away.
The facility must also support complex barcode readers for retail delivery and RFID scanning infrastructure.
The floors are sometimes embedded with wire guidance systems for automated turret trucks. The power and data requirements to run a modern, high-throughput distribution center are just staggering.
An older building without the capacity to support this tech evolution is at a severe competitive disadvantage. Let's delve into the massive mechanical systems required to keep these structures habitable, starting with the HVAC.
Heating, ventilation, and air conditioning in a 500,000 square foot building is a massive engineering challenge.
The standard configuration places the HVAC units directly on the roof. Why is that?
Roof mounting is preferred for several reasons. Ground space is incredibly valuable. Every square foot consumed by a mechanical pad is a square foot lost for truck maneuvering or employee parking.
Plus the thermodynamic efficiency.
Yes, roof mounting allows for a more thermodynamically efficient distribution of conditioned air. Pushing cold air evenly across a massive floor plate from a centralized ground unit is incredibly inefficient. By distributing multiple units across the roof, you create localized temperature zones that drop air directly where it is needed.
The core components of these systems are massive. You have the air handler, which utilizes heavy-duty blowers to push the air through the facility.
You have the condensing unit, containing the compressors and refrigerant loops that actually perform the heat exchange.
And you have the ductwork, the circulatory system that distributes the air and manages the return flow. Depending on the building's use, you might encounter several specific HVAC architectures.
The standard is the rooftop HVAC, a packaged unit providing both heating and cooling.
In older or more rudimentary warehousing, you might only see suspended unit heaters.
Right, these are simply large, gas-fired blowers hung from the ceiling to keep the ambient temperature just above freezing to protect inventory and the sprinkler pipes.
For facilities with varied operations under one roof, you see zone control systems. These utilize motorized dampers within the ductwork.
allowing the system to direct cooling to a heat-intensive manufacturing sector of the floor while simultaneously directing heating to the administrative offices.
Now, in highly specialized environments like advanced electronics manufacturing, you might encounter underfloor air distribution or UFAD.
This system utilizes a raised floor, pumping conditioned air into the plenum space beneath it. The air then rises naturally through floor grills, providing highly efficient, localized cooling while simultaneously sweeping airborne particulates upward toward ceiling returns.
It maintains a highly controlled cleanroom environment. Finally, for sheer heating efficiency in high-bay structures, radiant heating is common.
Instead of blowing hot air, which naturally rises to the ceiling where no one is working, radiant tubes heat surfaces directly via infrared radiation, keeping the heat at the floor level where the personnel and machinery operate.
Let's move from air to fire suppression. The sheer variety of fire suppression systems is fascinating. The sprinkler systems in these buildings are a masterclass in industrial risk management.
A sprinklered building is protected by a massive network of interconnected pipes, risers, and mains linked directly to the municipal water supply and monitored by automated alarm systems.
But the type of system installed tells you exactly what the building was engineered to hold. Walk us through the 5 types. The most prevalent is the wet pipe system.
The entire pipe network is constantly pressurized with water. When a fire occurs, the ambient heat rises, melting a fusible link or bursting a glass bulb in the specific sprinkler head directly above the fire, releasing the water. It is simple, reliable, and instantaneous.
But a wet pipe system is useless and in fact disastrous in an unheated building in a northern climate.
The water would freeze, expand, and shatter the entire pipe network. For unheated spaces, the engineering solution is the dry pipe system.
In a dry pipe system, the pipe network running through the unheated warehouse is filled only with pressurized air or nitrogen.
The water is held back by a specialized dry pipe valve located in a small heated enclosure. When a fire triggers a sprinkler head, the air pressure in the system drops. That drop in pressure trips the valve, allowing the water to violently rush into the pipe network and discharge over the fire.
There is an inherent delay in a dry pipe system while the water travels, which means the fire can grow larger before suppression begins.
To combat this, and to prevent accidental water damage in highly sensitive environments, engineers use pre-action systems.
These are essentially dry pipe systems that require a secondary trigger.
Exactly. The water will not flow into the pipe simply because the sprinkler head is damaged. A separate electronic heat or smoke-activated device must also identify a fire to open the primary valve. This dual verification is standard in data centers or facilities housing high-value, water-sensitive inventory.
When you move into heavy, hazardous industrial processes like chemical mixing or munitions manufacturing, you encounter the deluge system.
Unlike standard systems where only the heads directly above the fire open, all the sprinkler heads in a deluge system are permanently open. The pipes are dry. When a sophisticated fire detection system senses an unusual fire hazard, it opens a massive deluge valve.
And massive amounts of water absolutely flood the entire zone simultaneously. The volume of water released by a deluge system is catastrophic to the facility, but it is the only way to suppress a fire that could otherwise result in an explosive chain reaction.
And for maximum reliability, some facilities use a combined dry pipe and pre-action system, layering fail-safes upon fail-safes.
It is also critical to understand that water is not the universal solution. If a facility manufactures highly reactive chemicals or houses massive banks of high-voltage electrical transformers, spraying water on a fire will cause electrocution or violent chemical explosions.
In these specific, single-purpose or special-purpose areas, you will find gaseous suppression systems frequently utilizing carbon dioxide.
These systems function by rapidly flooding the sealed room with CO2, displacing the oxygen and suffocating the fire without leaving residue or causing short circuits.
The safety protocols for these systems are extreme, as they are inherently lethal to any personnel trapped inside during a discharge. They are used to protect electrical equipment, gasoline, and paint.
That brings us perfectly to the power grid itself. An industrial facility requires a massive electrical intake, far beyond standard commercial lines. The power is delivered as a 3-phase electrical supply,
which provides the continuous, smooth power wave necessary to run heavy industrial motors without burning them out. But that power comes in at a highly elevated voltage, which must be stepped down using transformers via electromagnetic induction.
A commercial inspector will note the type of transformer infrastructure on site. You have standard pull transformers for smaller, older facilities.
As power demands increase, you move to mat transformers, which are heavy-duty cabinets secured on concrete ground pads.
And for massive logistical hubs or heavy manufacturing, you will see pad transformers. Essentially, a synchronized array of multiple high-capacity mat transformers sitting on a dedicated reinforced concrete foundation, often enclosed by security fencing.
The utilities assessment also requires a close look at water and sewage, particularly if the facility is located in a rural or newly developing industrial park without robust municipal services.
If a heavy manufacturing plant relies on well water and septic systems, the due diligence mandates a comprehensive hydrogeological report.
A hydrogeological report is a serious undertaking. It requires drilling boreholes to evaluate the subterranean aquifers. It determines the flow rate, checking if the aquifer can sustain the massive daily water consumption of the industrial process.
It analyzes the chemical quality of the groundwater, and critically, it establishes baseline data so the owner cannot be falsely accused of contaminating the water table later.
Let's shift from the infrastructure to the pure physical logistics of the structure, starting with the floor loads. This is a point of failure that ruins many industrial deals.
The Ontario Building Code dictates strict structural requirements, measured in pounds per square foot. This capacity is split into two distinct engineering calculations: the live load and the dead load.
The dead load is the static weight of the building itself. The foundation and columns must support the immense weight of the concrete walls, the steel roof trusses, and massive rooftop HVAC units.
The floor slab, however, is primarily concerned with the live load. This is the dynamic, shifting weight of the operation. It includes the workforce, the heavy machinery, the forklift traffic,
And the massive, concentrated point loads created by the feet of steel pallet racks stacked 30 feet high with dense inventory.
If a seller cannot produce the original architectural and engineering schematics proving the engineered floor load capacities, the buyer has a massive problem. You cannot visually inspect a concrete slab and determine if it can hold 500 pounds per square foot or 1,000 pounds per square foot.
Without documentation, a buyer must retain structural engineers to conduct destructive testing, drilling core samples to determine the slab's thickness and sub-base compaction.
The interface where that inventory enters and exits the building is the loading dock array, which is a highly engineered logistical choke point. A standard dock provides direct truck-level loading.
The dock door is equipped with shelters or dock seals, heavy-duty, compressible foam pads or inflatable canopies that create a weather-tight seal against the back of the trailer.
This prevents conditioned air from escaping the facility and keeps rain or snow off the loading equipment. The topography of the land heavily influences dock design.
If the site is flat, the developer must excavate dock wells, which are declining concrete ramps that allow the trailer to back down below ground level so the truck bed aligns perfectly with the finished floor of the warehouse.
And you must also have grade-level access doors. These are massive overhead doors that allow a forklift or an entire flatbed truck to drive directly from the exterior parking lot straight onto the warehouse floor.
A facility without an appropriate mix of truck-level docks and grade-level doors is logistically crippled.
Okay, imagine owning one of these massive spaces and deciding what to do with it. Once we understand the physical reality of the building, its age, its systems, its structural capacities, we have to confront the invisible legal matrix that dictates what we are actually allowed to do with it.
We are entering the legal labyrinth of zoning, redevelopment, and the foundational concept of highest and best use.
Highest and best use is the cardinal rule of real estate appraisal. It is the use that, at the time of the appraisal, is physically possible, legally permissible, financially feasible, and results in the highest present value in money or amenities over a given period.
Determining that use is a complex analytical math exercise. You are essentially running parallel financial models. You analyze the property as improved land, calculating the cash flow and value of the existing structures as they currently operate.
Then you analyze the property as vacant land, calculating the value of the raw dirt minus the cost of demolishing the existing structure, plus the projected value of a brand new, optimally designed facility built in its place.
If the residual value of the hypothetical new development is significantly higher than the value of the existing operational property, then the current structure is economically obsolete.
The highest and best use is demolition. But identifying the highest financial return is only the first step. The proposed use must survive the gauntlet of municipal bureaucracy. The legal framework governing what you can build is tiered. The macro-level document is the official plan.
The official plan is drafted by the municipality under the authority of the Planning Act and approved by the Ministry of Municipal Affairs and Housing.
The official plan doesn't deal with the height of a specific loading dock. It deals with the 50-year vision for the city. It dictates which broad swaths of land will be dedicated to heavy industry, which to residential growth, and how the regional transportation network will support them.
The official plan is the philosophy. The zoning bylaws are the law. Zoning bylaws are hyper-specific granular regulations that control exactly what can happen on a specific parcel of dirt.
They dictate the exact permitted uses and construction types. If your property is zoned for light warehousing and you install a heavy manufacturing press, you are operating illegally. The bylaws strictly control development parameters through lot coverage restrictions.
Those restrictions dictate the maximum density of the site. They establish minimum setbacks, meaning you must build exactly 50 feet from the front property line and 20 feet from the side yard.
They dictate the required frontage and yard requirements, the mandatory landscape buffers, and the maximum building height. You are constructing your multi-million-dollar asset within an invisible, rigidly defined legal box.
What's fascinating here is what happens when the municipality changes the rules, but your building is already there. If the city updates the zoning bylaw and suddenly your specific industrial process is no longer permitted in that zone, you do not have to immediately shut down.
The law recognizes a concept called non-conforming use. Because your operation legally predated the new bylaw, your use is grandfathered. You have a legal non-conforming right to continue operating.
But that grandfathered status is fragile. If the owner ceases operations for a specified period, or if the building burns down, the non-conforming right is often extinguished.
And if a buyer acquires the property and wants to slightly alter the use or expand the footprint of the non-conforming structure, they immediately trigger a legal conflict with the municipality.
If the buyer's proposed use fundamentally violates the zoning, they must apply for a zoning amendment or a rezoning. This is a brutal, expensive, and highly political process.
It requires public hearings, extensive engineering studies, and often takes years, during which the buyer is paying carrying costs on a vacant property.
If the proposed change is minor, perhaps the bylaw requires a 50-foot setback, but the architect needs to build at 48 feet to accommodate a specific truck turning radius, the buyer can apply to the Committee of Adjustment for a minor variance.
It is a faster process, but still requires proving that the variance meets the general intent of the official plan. Assuming the zoning is secured, the final administrative hurdle is site plan control. This is where the municipality scrutinizes the micro details of the overall design to ensure it integrates safely with the surrounding infrastructure.
The site plan control process requires the submission of exhaustive engineering drawings. The city traffic engineers will review traffic impact studies to ensure the local intersections can handle the influx of heavy transport trucks.
Civil engineers will review the grading and landscaping plans to ensure the massive concrete roof doesn't shed rainwater that floods the adjacent properties.
They will demand a photometric plan to prove the exterior security lighting doesn't bleed into nearby residential zones. They analyze the turning templates to guarantee a massive municipal fire truck can seamlessly navigate the property.
Once every municipal department signs off, the developer must enter into a binding site plan control agreement, legally committing to build the site exactly to those approved drawings.
This intense regulatory framework reaches its apex in dedicated industrial parks. These are master plan districts, often designed in accordance with the stringent guidelines of organizations like the Society of Industrial and Office Realtors, or SWAR.
An industrial park is engineered to handle massive logistical throughput while strictly containing the negative externalities of heavy industry. The zoning and covenants within these parks aggressively regulate noise decibels at the property line, seismic vibration limits, and the emission of noxious odors.
They enforce strict containment protocols for radiation hazards. The design integrates heavy landscaping berms, retention ponds, and strategic road layouts to act as physical buffers, isolating the intense industrial activity from the rest of the community.
It is a highly choreographed system, but we need to guide you into the darker side of industrial real estate. Let's look at the detrimental conditions and hidden red flags that routinely destroy commercial transactions, things that kill deals. The first category is restricted access and easements.
An easement is a registered legal right allowing a third party to use a specific portion of your land for a specific purpose. It is an encumbrance on the title. While registered easements don't stop a transaction, they severely impact land utilization.
Imagine purchasing a 10-acre site with the intent of building a massive expansion to the existing warehouse. During due diligence, the survey reveals a 60-foot wide utility easement running diagonally across the rear of the property, protecting an underground natural gas line or municipal underground storm sewer.
You legally cannot build a permanent structure over that easement. Your usable acreage and your highest and best use just evaporated.
Legal restrictions are frustrating, but environmental nightmares are terrifying. Finding out past uses, like underground oil tanks or dumping hazardous waste. The liability regime we discussed earlier means that purchasing a contaminated site without securing the proper legal protections can instantly bankrupt a company.
And the threat doesn't just come from within your own property lines. The surrounding industrial ecosystem is equally dangerous.
Right. There is a specific, terrifying scenario from the text. A neighboring metal recycling facility causing soil contamination that bleeds into the seller's property without their knowledge.
Contaminants leach into the soil, hit the groundwater aquifer, and form a subterranean toxic plume that slowly drifts across the property line, contaminating the clean site. The buyer is now facing massive remediation costs and complex litigation to prove they didn't cause the pollution.
This is why comprehensive soil testing is standard operating procedure. We need to differentiate between the two types of testing. Environmental testing, typically starting with a Phase 1 and moving to a Phase 2 environmental site assessment, involves drilling boreholes to test for chemical contamination.
Geotechnical testing, on the other hand, is purely structural. Engineers drill boreholes to analyze the physical makeup of the earth. They need to locate the groundwater location and determine the soil makeup for structural support.
If the geotechnical report shows the soil is too weak to support the massive point loads of a concrete industrial building without driving expensive steel pilings 50 feet into the earth, the financial feasibility of the development collapses.
When red flags are identified, whether environmental or structural, the transaction enters a critical renegotiation phase. The buyer will demand substantial price reductions. If the seller refuses, the deal dies.
Speaking of structural red flags, there is a massive misconception regarding vacant industrial buildings. People assume an empty concrete box is inert and safe. The reality is that an empty property presents severe safety and financial hazards.
Without climate control, the thermal expansion and contraction of massive structural elements accelerate. Roof membranes dry out and crack.
Moisture in a sealed, unheated building leads to widespread mold proliferation. Furthermore, there are hidden structural imperfections in below-ground foundations that can be compromised by hydrostatic pressure.
Vacant properties attract massive liability on the exterior too. Stored toxics left behind in unsecured areas.
They're also magnets for vandalism and theft, particularly the stripping of valuable copper wiring, which leaves exposed external wiring.
And if the sprinkler systems have been drained or the fire alarm panel is deactivated, the building is in massive violation of fire code compliance. A commercial real estate professional must assume the worst.
All right, assuming the environmental reports are clean, the zoning is verified, and the structural integrity is intact, we move to the final phase, preparing the asset for the market. How do you actually list a behemoth property? It all starts with the mathematics of space, area calculations.
Accuracy is paramount because industrial real estate is valued and leased on a strict price per square foot basis. The industry relies on standardized measurement protocols, governed by the standards set by BOMA, the Building Owners and Managers Association, and IPMA.
BOMA standards dictate exactly how to calculate floor-by-floor areas and how to differentiate between the gross area, the rentable area, and the usable area. Industrial measurement is unique. Measurements might include the exterior wall.
And in certain architectural configurations, you must calculate the area based on the drip line.
The drip line.
Yes. If the massive steel roof overhangs the exterior walls, creating a covered loading area, the footprint of that overhanging roof, where the water drips off the edge, may be incorporated into specific area calculations. This prompts the need for professional measurement companies.
Let's do a rapid-fire breakdown of the vocabulary of space. You have to speak the specific language of industrial geometry. We have the bay depth.
That's the distance between the structural columns moving from the front of the building to the back.
And the bay width.
The distance between the columns moving side to side.
Then there is ceiling height.
The absolute vertical distance from the finished floor to the inside overhead surface of the roof deck. It is higher than the hanging joists.
Right, which is different from the clear span.
Clear span is the entirely unobstructed vertical and horizontal area. If you have deep steel trusses hanging down, your clear span, or your truss height, is lower than your ceiling height.
In modern logistics, the demand is for high cube or high bay facilities.
Buildings engineered with abundant vertical space, allowing operators to deploy automated systems that stack inventory high in the air.
On the exterior, the most critical metric is the truck turning radius.
The calculated arc required for a commercial transport truck to maneuver. Today's standard is a 53-foot trailer. If a truck cannot navigate the turning radius, the facility is functionally obsolete.
The final pre-listing strategies involve assessing exterior structures to add value. You have accessory buildings, which are used for raw materials.
And external improvements like heavy-duty truck aprons.
With the physical and legal reality fully documented, the seller can reduce marketing time by front-loading the due diligence.
They collect surveys, environmental reports, and floor plans before listing. By providing a fully vetted due diligence package on day one, the seller compresses the timeline.
And crucially, mitigating detrimental factors before the listing goes live. If the seller chooses to list the property as, they must understand that the detrimental condition will aggressively impact the marketability.
Sophisticated buyers will deduct the entire repair sum plus a risk premium from their offer price.
So, what does this all mean? We have covered a tremendous amount of ground today. You've just decoded a vast complexity, from recognizing a single-purpose building on your next drive to understanding the hidden world of deluge sprinklers and UFAD HVAC systems.
We've navigated the strict rules of the Ontario Building Code and the rigid walls of municipal zoning.
What is your final take on all of this?
Critical thinking is essential. A building is not just a structure, it's a legal, environmental, and financial ecosystem that must be carefully unraveled by verifying source documents and leaning on third-party professionals.
It is a world where precision is everything. And I want to leave you with a final, lingering, provocative thought. We've talked about how barcode readers and wideband radios have changed these buildings, but as we move into an era of hyper-automated, AI-driven logistics with drone deliveries and fully robotic warehouses, how long will it be until even today's highly advanced general-purpose buildings become obsolete, single-purpose relics? Next time you drive past a massive concrete distribution center, ask yourself, are you looking at the future of commerce or a very expensive future brownfield? Thank you for joining us on this deep dive. We will be back soon to unpack the next layer of the systems that run our world. Until then, keep analyzing the structures around you.